We're going to take a look at 2-2, which is ratios. We did some work already with the proportion part of this. We're just going to do some word problems now. So in percents, what we want to remember in percents is that percent means that percent means um, part divided by whole, and the whole is always 100, so it's out of 100%. So if I said, let's go with let's go 75%. Okay, and 75% means 75 out of 100. Okay, and so when I do example one, Ms. Thompson's algebra class received their test backs. 40% of the students received a B. Okay, so 40% is 40 out of 100. Okay, of the 80 students received a, if 80 students received a B, how many students took the test? So again, this is a part divided by the whole. The question is how many total students? How many students were there that took the test? That's the whole part. And 80% of them, or the whole thing, the part that got a B on the test was only 80. 80 of her students got they got a B on this test. So the 80 goes on top. A couple different ways we talked about that you could solve these. You could try to say what times 40 gives me 80, and then the bottom number has to follow that same ratio by multiplying. You could also do cross multiplying. So that's the one that I see most people doing. So we'll do that one. 80 times 100, and then 40 times x. 80 times 100 is 8 with 3 zeros. Divide by 40. A 0 is going to cancel out, and then 800 divided by 4 is 200. So I end up with, there were 200 students that took the test, and 80 of them got B's. Okay, so go through the percentage parts of these problems using the fact that 18% would be 18 over 100. The 85% is 85 over 100. Similarity. So when we look at similar triangles, oh, there's a missing x here. We want the parts of the triangle to match up. Okay, and so the same thing with the rectangles. Same thing if I had a quadrilateral. Okay, and any other type of shape, an octagon. Okay, and if we've got similar shapes, then the sides are proportional. So I need the sides to match up. And so when I look at this, I've got the bottom of the triangle and the bottom of the triangle. I'm going to put those two things in a ratio, but I'm going to put them in in a fraction form. So I started here. This was 1 and this was 2. This was top and this was bottom. Okay. The same thing has to happen when I look at the hypotenuse of this triangle. This has to go on the top and this has to go on the bottom. Okay. It has to be the same ratio here. It has to go exactly the same. Okay, so I get x over 4 equals 10 over 5. That's one way that I could create this ratio, and I could cross multiply and divide, and that would be fine. Let's take I'll look at another way that I could create this ratio. I could, here was our x. I could say inside my triangle, I could say that this would be the top and this would be the bottom. So I could do 4 over 5, which would mean that this would be the top and this would be the bottom in my second one. So I would get x over 10. This one's a little bit easier to see because I just multiplied the 5 times 2 to get 10, and the 4 times 2 would give me x is equal to 8. Okay? But ultimately, you can use cross multiplying in here, so I get 4 times 10 is equal to 5 times x. So 40 equals 5x, divide by 5, and x is equal to 8. Okay, so I end up with x equals 8 either way, and it doesn't really matter. Okay, but you have to make sure you're using part to part. So in this rectangle, I'm going to use the fact that this is the top and this is the bottom. And then on my second one, this is my top and this is my bottom. And I'm just going to put them in a a proportion. So I end up with 13 over 7 is equal to x over 35. I'm going to show you again what happens when I'm looking at comparing these. So I would do 7 times 5 to get 35. So I have to do 13 times 5 to get the top. Whatever I do to the bottom, I have to do to the top. So 13 times 5 is 65. I didn't have to do cross multiplying, but if you did cross multiplying and dividing, you would end up with the same thing. Okay, you should end up with x equals 65 for that problem. On the back here, we're using indirect measurements. This is something that I actually used when I was working at home trying to decide if a tree was going to fall and hit my house if I were to attempt to cut it down. Well, I did this exact type of problem. I stood, used my shadow and used the tree shadow, measured them. I found out how tall the tree was, and then decided that it was better for me to hire somebody. Even though I paid them $400 to cut down one tree, it was better for me to hire them than it was for me to try to cut it down myself, because I like my house too much, and if it fell the wrong way, it would have hit my house because the tree was too tall. Okay, so it's a kind of an important skill for you to be able to use. It's something that you might actually be able to use later on, an indirect measurement. So I'm measuring something without actually going up and measuring it. I measured my tree without actually going up and dropping a tape measure from the bottom of the tree and climbing all the way to the top. So here's a picture. I've got Susie here, nice curly-haired Susie. So Susie is 5 feet tall. She has a shadow that's 11 feet long. She's standing next to a tree. Here's the tree, nice curly-topped tree. The tree has a shadow that's 37 feet long. We want to know, how tall is the tree? Okay. So this is going to be a proportion situation. I've got different parts that are the same in this problem. I've got Susie's height. I want to know the height of the tree. I've got Susie's shadow. And I know the shadow of the tree. So I'm going to create this this situation where I've got my proportion, and I'm going to put top and bottom for Susie, 5 over 11, and I've got top and bottom for the tree, x over 37. Now in this situation, 11 times something will not give me 37. That something would not be a really nice number. I could figure it out, but it would be a lot easier for me, I think, to do 5 times 37 equals 11x. Nice cross-multiplying problem here. 5 times 37 is equal to 185. And then divide by 11. Gives me that x is equal to 16.8, which means that the tree was 16.8 feet tall. So the tree is 16.8 feet tall. Okay, we're going through and we're doing the same type of problem. Tommy's taking some steps, okay, and walking some miles. We want to know how many steps would be miles, so there's a proportion there. Standing at the base of a cliff, there's a shadow and a height of a person. The cliff has a shadow, kind of like our tree problem that we just did. Okay, going through and using proportions, following along, matching parts up of these different problems. Parts of a triangle, parts of a story problem, matching them up to be able to use a proportion.